Alright, so we are going to pick up with the stuff like 12 through 17. So these ones are a little bit different, but yet also the same in a sense. So these say to evaluate the expression, given that, apparently I can't. The cosine of A is equal to 4 over 5 with 0 less than A less than pi over 2, and sine of B is negative 15 over 17 with 3 pi over 2 less than B less than 2 pi. Well, okay, yes and no. So like yesterday we did the ones where it told us something and then we had to find the angles that we knew to add them together. Right. Basically now they're telling us these are the values that are getting plugged in, but we're going to have to find all the different values so that we can do what it's asking. So we're getting ready to have to do some triangles to find the other side, and then we'll be able to continue. But once we do it, now you won't need to do it again in your homework because I will have already done it for you.
We're technically given some of the angles though, right? Like pi over 2 and 3 pi over 2? In these types of problems?
So yes and no. So like with these, this is telling us where angle B is. So basically we can graph it. I can graph A and I can graph B on like the coordinate plane with these values. So then I can find like what is the tangent of B, what's the cosine of B, because right now I'm just given the sine of B. Yeah, so I'm going to find all the different the 3 trig functions for each of them, and then I'm going to use that to plug them into the sum and difference formulas to solve it. So, all right. Yeah. All right, so I need to know where A is. So A is between 0 and pi over 2, which means it falls where?
Quadrant 2. No. 1.
Quadrant 1.
I'm stupid.
Okay, so.
Is this like an example in the book?
Yeah, so this is setting us up to do the next couple problems.
Oh, so these are notes.
Well, no, it's technically part of the homework problems.
It's just like
It's for problems 12 through 17, but we can't actually do the problems until we have this worked out. All right, so I have the cosine of A, so obviously this is A here. So the cosine is adjacent over hypotenuse, so 4 and 5. And this is a special triangle. What is the other side? 3.
That's like A.
Yeah, for angle A. Okay, so with this one, the sine of A is equal to what? What would the sine of A be equal to? 3 over 5. The cosine of A was given to us. That is 4 over 5. And then the tangent of A would be what?
3 over 4.
3 over 4. Okay, so I am setting this up for you. For your homework, you will not need to redo this triangle. But on the quiz, if I give you a problem like this, you will have to set the triangle up yourself. Okay? Or you're going to have to remember them from the homework. One of those 2 options. Okay? So make sure you understand the principle of what's happening. Maybe even try to go through when you go to do the homework and reset them up yourself, or at least when you go to review for the quiz, it's test, however we do it. I think we're going to do a quiz and then a test. Just to make sure you understand how you're setting up these triangles. Typically, I just pull from the book, so it's not like I'm going to change them. But you've got to make sure you understand the principle of how to do it so you can do it when we get there.
Do we have to find the flipped functions for this too, or just for
No, so since we're with sum and difference, we only need sine, cosine, and tangent. So I'm just going to do those three. I don't need to do the other ones.
Okay.
Yeah. All right, so that's triangle A. So now I need to do triangle B. Okay, so this one is from 3 pi over 2 to 2 pi. So where's that?
Quadrant 4.
Okay. Yeah, down here. Close enough. That's annoying me. It's not on the thingy. Close enough. Okay. Just a lost cause at this point. All right, so this is going to be angle B in here. Okay. Now, sine is opposite over hypotenuse. Okay. Which value is going to be negative?
15.
Okay, the 15. Okay, your hypotenuse can never be negative. So if you have something that's sine, okay, sine or cosine, it's always got to be the top value that's negative. Okay, if it's tangent, you have to look at truly where it is in the quadrant and decide which one is positive and negative. Okay, based on your y and your x values.
I have a question. The you know how there's like the 4 kind of quadrants of the unit circle, and then we have like 1, 0, and the different variations of that. Is it the same for a graph? Like as far as tangent values, like 1, 0, negative 1.
I mean, kind of. So like if, like with this one, or like, well, if I was told over here the tangent of B was equal to something, then my y value is going to be the one that's negative.
Okay.
And then my x value is going to be positive because of where it is. So part of having to know what quadrant it's in is so that you can decide which values are positive and negative.
Gotcha.
Your hypotenuse is always positive. It's not possible for it to be negative. So if you're given sine or cosine, you know your hypotenuse is positive. You know the other value has to be negative.
Okay.
So tangent's the only one you really have to work for.
Okay.
All right, so then I need the other side of this one.
17 squared is equal to. You have to do the back here, right?
Yeah. Well, anyways. Somebody will have to tell me what that's equal to. Don't know that off the top of my head.
I have a quick question. It's about the last one. Well, how did you get 3? Did you just know?
Well, yeah, technically I just know, but also the square root of 5 minus the square root of 4.
Oh, so
Or,
it's
sorry. That did not come out right. 5 squared minus 4 squared is 9, and then take the square root of that is 3. But 3, 4, 5 is a Pythagorean triple.
Okay, thank you.
So Miss Marshall may have talked about them. I'm not sure.
Probably did. I just don't remember.
Yeah, there's a few that are. There's like the 5, 12, 13 or something like that. I don't remember. Something like that. There's different ones that are considered Pythagorean triples, and that just was one that I know off the top of my head. For this one? I don't know. Maybe.
Patty got 8.
8. Does anybody else have it?
My calculator's good. It is 8.
Okay.
Yeah, well,
All right. All right, so now we have this. So I'm going to go ahead and list out my different, oh, this is actually B now. Okay, so my sine of B was given to me as negative 15 over 17. Cosine of B is 8 over 17. And tangent of B is negative 15 over 8. Okay, so now I'm going to use these values here when I go to do the problems. Okay, so now they're not off the unit circle. I'm using these that are given to me.
Oh, that's the easier to do.
Okay? So in general, when you do it, when it gives you an angle, you're using values off the unit circle. These problems are giving you variables, and now you're using the variables to solve them. Okay? So, let's see. 12. Sine of A plus B. Okay, what is that formula, like, identity, whatever you want to call it? What is that equal to? The sine of A plus B, how do I rewrite that?
Sine of A times cosine of B plus cosine of A times sine of B.
Okay, so remember with the sign ones, their sign, okay, positive or negative, is the same, okay, and it's not with its buddy. Okay, cosines are with its buddy and have opposite signs. Okay, so now sine of A is 3/5. Cosine of B is 8/17. Plus the cosine of A is 4/5. Sine of B is negative 15/17. And I do not want decimal answers. Not going to take them. Okay? Everybody got that? Because I'm sure somebody's going to try to give me a decimal and I'm not going to take it. Not happening. Okay? So you can try to cancel some stuff here if you want. Honestly, the better option, because of the fact that you've already got 5 and 17 on the bottom of both, is going to just be to leave that so you don't have to go back and do a common denominator. Because yes, I could cancel this 5 and 15, but if I do that, then I've got to go back and get a common denominator, and I'm going to end up back with multiplying it by 5. So over here, 8 times 3 is 24 over 5 times 17 is 85 plus 4 times 15, negative 60, because it's negative, don't forget the negative. And then 5 times 17, we already said is 85. And so now I get, what is that, negative 36 over 85, and you're done. What?
This, sorry, I'm just a bit confused. The top piece, does that also go number 12?
Yes, this is going to go with 12 through 17.
Oh, okay. Got it. Thank you. Is A and B the same thing every time? Like sine A and, like, are these going to be the same forever? Or do they change?
For these 12 through 17, yes. This formula is the same always.
But like when, like, so say we had like homework tomorrow, whatever, I don't really care. But like the next day, and we had to use like sine A and like and cosine B, and like that kind of
For
stuff.
problems 12 through 17, you will use this.
But only 12.
Yes. And then I posted the videos from yesterday.
Yeah.
It was the notes, and then I did it like as 2 separate things. So it's like a notes video and then a problems video. So it should make sense. And then if you, after you watch it, if you still have questions, you can talk to me about it. All right, let's do another one. 14, yeah. Tangent of A plus B. Okay, so what is the formula for tangent?
Tangent of A plus tangent of B over 1 minus tangent. Over 1 minus tangent A tangent B.
Your finger fell asleep or something?
Huh?
Your finger was moving.
Because I was trying to switch it to the eraser.
Oh, I was like, what is going on?
I can just double tap it and it switches, but it doesn't always do it. Sometimes it likes me and sometimes it doesn't.
You're about to write with the eraser. Don't do that.
Yeah, I've done that a couple times. It's really unfortunate.
Really? That is terrible.
All right, so the tangent of A is 3/4. Plus the tangent of B is negative 15/8.
Oh, we're still using the same,
Yeah, so these are staying the same the whole time. And then 1 minus the tangent of A times the tangent of B, so 3/4 times negative 15/8. Okay, on top, it'll be pretty easy for me to get a common denominator. I just need to multiply the 3/4 by 2/2. Okay, that'll give me an 8 on the bottom. So 6/8 minus 15/8 over, let's see, 1 minus 40, oh, that's going to end up being plus 45/32. So I'm going to rewrite this one as 32/32 just so that I've got the common denominator. So on top now I've got negative 9/8 all over 77 over 32.
Is it negative?
Oh.
45 negative? Yeah, no, yes, no.
Well, it was minus a negative, so it's positive now. And then I'm dividing by a fraction, so I need to do what?
Multiply by the reciprocal.
Okay, multiply by the reciprocal. So 32 over 77. 8 goes into 32 how many times? 4 times. So that's going to be negative 36 over 77.
This is actually probably the easiest thing I've done with fractions.
I just don't like it.
Don't usually like them.
They
too
usually
long.
work out pretty nicely.
That's what I'm saying. There's not anything super complicated once we figure that out.
All right, 16 is the cosine of a minus b. And what is the formula for that?
Okay. Cosine of A times cosine of B plus sine of A times sine of B.
All right, and then I've got to go back up. All right, cosine of A is 4 over 5. Cosine of B is 8 over 17. Plus sine of A is 3 over 5. Sine of B is negative 15 over 17.
This one's pretty much the same as
Yeah, it's pretty much the same sign.
Yeah. All right, so what do you say the bottom is like 85 or something?
Yes.
And then 4 times 8 is 32. And then that's going to end up being minus 45 over 85. So is that negative 13 over 85?
Yeah.
Where'd you get 3 over 15?
Is it 3? It's supposed to be 3 over 5, sorry.
That wouldn't be.
I don't really know why. I think I like wrote 15 because I was preparing for the 15 over 17 and just,
Well, no.
they all ran together. Pretty easy.
Yeah.
Cool. All right. Let's see. All right. So the next one, say to simplify the expression. All right. So starting with 20, we've got the sine of x plus pi. So I'm going to rewrite it in terms of either the sum or difference formula. Okay, and then I'm going to simplify things down. So like, for example, the sine of pi is going to go away because it's going to be 0. Okay, so it's going to make pieces cancel out because you have a variable and you have the numbers mixed in. Okay, so what would this be written out, okay, with the formula with these pieces in it?
Would it be sine x? No. Wait. No, I don't know what to do.
Hey, you got to start it. That's what matters.
Yeah. Is it cosine
This
pi?
sine, yeah,
tangent 5.
And then
plus cosine of X.
plus.
Well, pi's our
Sine of
favorite
pi.
number, and I figured we had to have tangent. Good job. Now we just tangent.
Okay, so now at this point, I'm going to evaluate the stuff that has pi's in it, okay? So I've got the sine of x times what's the cosine of pi?
Oh, I think it's pi over 2.
Negative 1.
-1. Plus cosine of x times what's the sine of pi? 0. Okay, so the cosine of x stuff is going away, so I'm left with negative sine of x.
Answer. Woo, got
Wait.
you.
Wait.
That is like the only one I understood.
No, I don't like any of this stuff. Really hate
Can we do another one?
Yes. We're going to do several.
Is this going back to those identities?
Nope. It's just what we've done in this section. All right, tangent of x minus 2 pi.
So it'd be tangent of x plus tangent of tangent of negative 2 pi.
It would be minus tangent of 2 pi.
That's why.
So for the tangent ones, the top sign stays the same. The bottom one changes.
And then 1 minus
Plus.
It's going to be plus. It's the opposite sign on the bottom.
Tangent of x, tangent of 2 pi. Okay.
Let me get this focused in so y'all can see this a little bit better really quick.
So regardless of the sign, the top will always be the same, and the bottom will be the opposite of the same.
Yes.
We don't have the tangent set up for 2 pi though. Did y'all just distribute or?
The tangent for 2 pi.
Yeah.
So I don't have them on these ones, but it's just the y over x value, so it'll just be 0 over 1 is what?
I know. I mean, like you can up there, like tangent of a plus b or minus b doesn't have a 2 pi in it. So I was wondering how y'all.
So 2 pi is just going to be a number. So we're going to evaluate tangent at 2 pi to figure out what that is. So it's going to cancel stuff like we just did in this one. We replaced the cosine of pi with -1 because that's equal to. We're going to do the same thing with the tangent of 2 pi.
Okay, so we're replacing a and b.
I think this one was
with
easier.
x
Yeah.
and 2 pi. Okay.
Yeah, so x is staying because it's a variable. I can't do anything with it.
Yeah.
But then what is the tangent of 2 pi?
Tangent.
It's
0. So minus 0. Okay, so obviously that piece is going to go away in a second when I fully simplify. And then 1 plus tangent of x times 0. So that's going away. Tangent of x over 1 is just tangent of x. So that's just equal to the tangent of x.
Oh wow.
Okay, so that's the beauty of these ones. Now, once you separate stuff out, things are just going to cancel and go away.
Oh sweet. I like
And you're going to
this.
always be left with like a simple, like one piece function.
Are you ever gonna get a tangent one that the tangent is undefined?
It's possible.
How would you do that? You just wouldn't.
You would just say undefined. I don't think they give you any that do that,
Each say no thank you.
but I have to look. I don't know. It might just happen.
Yeah.
Oh,
But if that happened, I would literally just write on your paper undefined.
Okay.
See, we are a nice math teacher.
Let's just try this one. Tangent of x plus pi over 2.
Pi over 2 and 2 pi are the same on the table, right?
No. Pi over 2 is at the top.
so it would be
2 pi's on the side.
tangent x
Yeah.
plus. It's plus, right?
Yeah.
Yeah.
And then it's 1 minus tangent x. Oh, it's part of this tangent. Pi over 2.
Is it just equal tangent x?
So here is there. I don't know the pi.
Pi over
This is one of those undefined ones.
Yeah, so, okay, your book tells you that the answer is going to be cotangent. However,
No?
it doesn't really make sense because I've got something undefined. I've got two things that are undefined, meaning they've got to just go away.
So why are those undefined? Like.
Because it would be 1 over 0, and you can't divide by 0.
Oh, so pi over 2 is still equal 0?
No, pi over 2 is undefined.
Oh.
Well, for tangent, it's undefined.
Okay.
So, basically, at this point, what I want you to do, okay, is to write undefined. Okay, because we would not keep going with that if that
Do
happened.
like cosine and sine stuff.
Huh?
Do they want us to do what we did like last chapter with like cosine? Like making it where we have like sine over cosine on the top and bottom. I would be really sad.
Yeah, they want you to get that the answer is negative cotangent of x. However, it comes out as undefined, so that really doesn't make sense for you to get something that's like that. All right, let's do one more together, and then I'll have you do one on your own.
Be like a
Let's
nice one to
do
learn.
cosine. Cosine of x minus 3 pi over 2.
Oh, wait, we're
Yes.
Okay, so you have cosine x times cosine negative
Whoa.
3 pi over 2. Plus
It's just 3 pi over 2, but
plus sine x sine.
You just, the only thing you do with this is this tells you what's,
What happened?
it switched to the eraser, is this tells you what's going right here. Because it's either the same sign or the opposite sign, depending on the formula.
So if cosine, if it's like cosine A plus B, then there would be a negative. Thank you.
Yes.
That makes a lot more sense.
Alright, and then what comes after that?
Sine x times sine of 3 pi over 2.
Alright, so cosine x times, what's the cosine of 3 pi over 2? Plus sine x, what's the sine of 3 pi over 2?
0, 1. Or no, sine, my bad. Negative 1.
Negative 1. So that is negative sine of x.
I like these problems.
Alright, last one for you guys to do on your own. 30 cosine of x plus 5 pi over 2.
I have a question.
So everybody should have paper out doing this one.
I have a question about number 26. Shouldn't it be cosine of x times cosine of 3 pi over 2 plus sine of x plus cosine of 3 pi over 2?
No. Cosine, it stays with its buddy.
What buddy?
Like cosine and his buddy cosine, and then sine and his buddy sine.
Oh, is it this?
It says 5 pi over 2, right?
I don't know if I did it right, but I did it.
Oh, we got number 16.
Y'all should not need unit circles for these.
I can't remember the. I see number 16.
I definitely did it right.
I just am blind and don't know how to do it.
I get 5 pi over 2. Wait,
That's,
I don't think that's even.
that's not even, yeah.
It's not, but you should easily be able to find it. 5 pi over 2 is easy.
It's the fourth quadrant, right?
No. It's an axis. That's why I said it should be easy. Pi over 2s are always on the axis.
Yeah, that's why.
Okay. Okay, I got there. Okay.
I must be stupid because I don't get it, but that's okay.
I think I don't think I understand, but I wrote something.
If you get like 1 times something, is it just?
Just whatever the time something is. Alright. So what's the formula?
Cosine of x times cosine 5 pi over 2 minus sine of x times sine pi over 5 pi.
I got that right, guys.
Why do we get a minus for that?
Because it's
the
positive.
formula.
It's opposite sign.
Oh.
So then it's cosine of x times 0
0.
minus sine
Oh, that would be my first
times
mistake.
1. So
Oh
what
my
would
gosh,
this be
wow.
negative sine of x?
Why would it be negative? Oh, because. Yep.
Bro, I was
Oh, why am I
literally-
stupid? I
I
had
told
it
you
right,
right.
and then I just
That's why.
didn't do it right. So I didn't have it right, actually.
It makes decent sense.
I got it. I just mixed up my sign and.
I like those ones are satisfying. The other ones we did earlier
Is this
were
homework?
hard.
Okay, so is the ones that you gave us 3 and 7 plus whatever you're gonna give us now do tomorrow?
Yeah. It depends on if everybody is working for the last 15 minutes of class.
This actually makes sense.
So cosine of x equals 0 and sine of x equals 1. How do we get 1 for that?
What?
Yeah, I don't
The sine of 5 pi over 2 is equal to 1. Because it's at the same place as pi over 2 on the unit circle.
Oh, okay.
Alright, so added on to what you got yesterday is 13, 15, 19, 23, and 25.